All right, so look at this problem. Integral from 0 to pi over 30 x tan square of 10x dx. So to handle this type of the question, what I usually like to do is to make a u substitution first, because we have 10x here. And it's better to make the u substitution as the beginning to avoid more chaos, in the future. So we do that. U equals 10x, and then du equals 10 dx, right? And x is from 0 to pi over 30. So correspondingly, u is become from 0 to pi over 3. Okay. So make this u substitution here. We got from 0 to pi over 3, x becomes into u over 10, right, times tan square of u, and dx, which is du over 10 here. So factor the constant out. We're going to have 1 over 100 integral 0 to pi over 3 u tan square of u du, right? So now, don't you agree, it is problem, it is very simple, right? It looks like simpler. I think I should say this, because this problem simplify into this, and then we're going to use again the integration by parts. Since when we do the integration by parts, it's a u dv equals uv minus v du, right? So to make less confusion, let's change this variable into another one. So the problem becomes into 1 over 100 integration from 0 to pi over 3. Let's see, I don't know, let's do m tan square m dm, okay, dm. So that we can set our u equals m, and our dv equals tan square m dm. So that du equals dm, while the v, if you remember this, so the integration of tan square equals tan minus x. Okay, so maybe write it here. Integral of tan square x dx equals tan x minus x plus constant c. Okay, so that's another information you'll use. So with that in mind, you can see that this v gonna equals tan m minus m. Okay, so we apply the integration by parts. So it gives us, it's 1 over 100, right? So let's use a big bracket here. uv, right, which is m times tan m minus m, and then evaluated from 0 to pi over 3, okay? And then minus the integral from 0 to pi over 3, so it's going to be v du, right? V is here, du is here, so it's going to be tan m minus m, and then dm, okay? So that is the integration by parts. So, yes, okay. Okay. So now, as you can see right here, the integral of tan of x, so that's another information, integral of tan x dx equals ln of secant, absolute value of secant x plus constant c. Okay, so that's another information you will use. So to continue to this part, so let me write it here. So it becomes 1 over 100, you know. So it's m 10 m minus m squared, right? From 0 to pi over 3, okay. And minus ln of secant m, right? And then minus m squared over 2, evaluate it from 0 to pi over 3, right? Pi over 3. And then, yeah, and then that's it. So all you need to do is to make sure that you got this information, it is correct, which means that what is 10 of pi over 3, so which is, let's put it here, so 10 of pi over 3, which is square root of 3, and secant pi over 3, which equals 2, okay, which equals 2, and yeah, and pretty much secant of 0, right, which is 1 over cosine of 0, which is 1. Secant of 0 is 1. So if we put all these pieces together, so it becomes into 1 over 100. So it's you see, so it's a pi square root of 3 over 3, right, minus 3, right? So right here, 0 is all 0. And then minus, so for here is 0, here is also 0. So it's just evaluate a pi over 3. So it's a ln 2 minus pi square over 9 and then over 2. So it's a pi square over 18. Right, over 18. And yeah, so that's the answer for this. Of course, you can do the simplification, but you get the basic idea of how I solve this problem, right? So from the beginning, we make a U substitution to simplify the problem into this way. And to make less confusion, I change the variable here. And then after that, I make the U integration by parts, set my U, my dV, and then use a couple of trig integration result. And then basically the integral of 10x is ln of absolute value of secant x. And also the integral of 10 squared is 10x minus x. So yeah, and then this is what we have. Okay, so thank you for watching.